recall that for a function, we have an equation where for every input, there is only one output. So we are now going to focus on, well, what are the allowable inputs to that function? And as a result, what are the outputs for those inputs? So that's where domain and range come into play. So domain will be all the valid, and this is going to be for functions, so we'll make a note, for functions. So all valid inputs to the function. Now, let's take a look at this term valid. What is valid? Valid means that the input results in a defined output. So before we jump over to what range is, let's just take a look at it, an example function. Let's say we have f of x equals 1 over x squared minus 4. So we have this function, and we're looking at this, and we want to determine what are the possible inputs for this function. And to determine what the valid inputs are, I would want to look at any possibility that would result in something that would be undefined. That might be my first thought. So the most common place where things are undefined in math classes, or what people reference the most, is when we divide by 0. So I might want to check out, well, where is this denominator going to equal 0? So what value of x, when I square it and subtract 4, would result in the value of 0? And if I think about that a little bit, I would notice that x equals 2 would result in a 0 for the denominator, and therefore the overall output would be undefined because I would have 1 divided by 0. But also x equals negative 2 could work, because when I square negative 2, I get positive 4, minus 4 equals 0. So I have these two values that are not valid inputs. So x cannot equal either of these. And therefore my domain would be all real numbers. So I'm allowed to plug in anything except 2 and negative 2, because 2 and negative 2 result in undefined outputs. And therefore, they're not part of our valid input range or interval. Now, what are the outputs that result from these inputs? Well, that is the range. So the range are the outputs that are produced by the function as a result of the valid inputs. Now, because domain is dealing with inputs, we're going to be looking at the x-axis or the x values. Range, dealing with outputs, we'll be looking at the y-axis when we analyze this stuff visually. And that's going to be our y values. But because we're using function notation more often, it could also be the f of x values. Remember, those are basically, or they, not basically, they are synonymous, right? Y and f of x are the same thing. They both are representative of the outputs. So we have a definition for domain and range. We may have a graph where we just have a bunch of points. So let's say we have a point. We'll actually label this axis. So let's go. So let's say we have some points. And we want to list domain and range. Now, because we're doing single points, we don't have to showcase a whole interval so I don't need to use like an interval notation. I'm just going to list the points that fall in the domain. So domain, remember, are the inputs. So that's going to come along our x-axis. So what x values are included in these points? Well, we have -2 here. We have -1. We have +1, 3, and 5. So my domain, -2, -1, 1, 3, and 5. I'm going to put braces around these numbers, and that shows that I'm just listing individual numbers. There's no range that is showing. So I'm not including values between -2 and -1, but rather just those individual numbers. And then for range, what do we have there? Range is going to be our output. So what are the corresponding y values to these inputs? Well, we have a -1 y value, we have a 0, we have 2 1s, and we have 1 2. Okay. So what's our range? -1, 0, 1, 2. And again, where am I getting these values? Domain comes from the x-axis, range comes from the y-axis. Inputs for domain, outputs for range. So that's when we have single points. But what if you have a continuous graph where all these points are connected? Let's say we have a graph We'll actually do one that is bounded for now, and then we'll do one that is unbounded. So domain. With this continuous graph, we will use interval notation. That way we can show all the numbers that are a part of each of the domain and range, respectively. Now, for domain. With interval notation, we just want the smallest value in the interval all the way to the largest value, and then just dictate whether or not it's included or excluded. So let's say we're at this point. Let's define this point, because that's the leftmost point along my x-axis. Let's call that point A, and let's call this rightmost point B. Okay, so this ranges between A and B along the x-axis. That's as far left as it goes and as far right. So the domain, again, is basically my coverage of the x-axis. So think, when I look at my graph, how is it covering the x-axis? So how far left would be A? A is included. All the way to B. B is not included because of that open circle. And there's the domain. Now for the range. Find its lowest point. Let's say that's C, and its highest point, let's say that is D. So range is coverage of the y-axis. And again, we always want to list least to greatest, which is why we're working from down to up in this case. So C, is it included? No, because there's a circle at C. Is D included? Yes, because there's a closed circle at D. So we're going to do C to D, and there's our range. Okay, so domain, all the valid inputs, that comes from the x-axis, so I'm seeking coverage of the x-axis. Range, all the corresponding outputs to those inputs, and that will become, or you'll be able to identify that by looking at the coverage of the y-axis. Now let's look at a graph that would be unbounded, meaning it's going to extend forever in either one or both directions. So we want to find domain and range. For domain, we're looking for coverage of the x-axis. So how far left does my graph go, and how far right? Now this thing doesn't have any breaks in between, and if it did, that's for a later time. But for now, we're just going to do full coverage without any discontinuities in the graph, meaning it's just continuous through the interval that is shown. So this goes How far to the left? Well, it goes left forever because this arrow here that's up in this top left corner extends not only up, but it's going to the left. So I know coverage of the x-axis extends forever in the negative direction, and therefore it's going to go towards negative infinity. Now, how far right does it go? Well, it reaches this point. We'll label that x value a, so it goes all the way to a. A is included because of the closed circle there. As for range, you're seeking coverage of the y-axis. So we say, how far down does this go? Well, the lowest point is over here. We'll call that b. So the range is closed at b. There's no open circle there, so b is included. How far up does it go? Well, this extends. Now, again, that arrow indicates it goes up forever. So that extension in the positive direction implies that we're going towards positive infinity with my outputs. So I would put an infinity parenthesis around it, and there is my range. So that is the conclusion of domain and range. You have definitions for both. I would write those down somewhere. And we have graph examples for something that's bounded, something that's unbounded, and even a way to analyze just a basic function rule. You're looking for things, again, it's important that you recognize that the inputs need to result in defined outputs. Okay? So look at your equation and ask yourself, what values would make this thing undefined? Another quick example, just to end the video. Let's say you had, you may be familiar with the fact that we can't take a square root of a negative number and get a real number. So although the square root of a negative is in fact a useful number, it's not a part of the real number set. So anything that is less than 0 or that's negative would be resulting in something that's undefined in a real number coordinate plane. So in the case of that example I wrote up at the top, x needs to be greater than or equal to 0 for the values to produce valid outputs. So in this case, the domain for us is anything greater than or equal to 0, which in interval notation looks like that. And again, why is that? If you take the square root of a negative, even if you try it in your calculator, it'll probably say error. But we're dealing with a real number coordinate plane. So if I want to plot real numbers, my output needs to be a real number. In the case where I take the square root of a negative, I won't have a real number. So it's not defined in our coordinate space. So therefore, it's not included in our domain. So that's another example where you can analyze the properties of our function itself to determine what the domain would be. And that's where I'll end the video.